Welcome back, everyone. In this video, I'm going to review the 4 steps of hypothesis testing, and then we're going to apply it to a one-sample t-test. So again, we have 4 steps that we're going to undertake whenever we're doing hypothesis testing. First, we're going to set our hypothesis, our null hypothesis first, and then our alternative hypothesis. We're going to determine what is our critical region, what is the area that we're going to be considering as low probability for finding our result in that area if the null hypothesis is true. We're going to calculate our t-statistic, and then we're going to make a decision. So let's do it. So a cognitive psychologist is interested in the impact of fatigue on observational learning. So how tired you are, does that affect your ability to learn by watching? A sample of 49 participants who had slept 4 hours completed a series of 10 trials on a cognitive test. The sample mean was 69 seconds, with a standard deviation of 14. Assume that a normal population has a mean of 75 seconds. We're going to use a two-tailed test with a significance level of alpha equals 0.05, and we're going to determine whether fatigue impacts cognitive performance. So let's take a look.
So what I've done first is I've set up the important information that we need. We had an N of 49, our mean is 65, the population mean was 75, and the standard deviation is 14. In this process, we're going to need to know the standard error of the mean and the t in order to figure this all out. But our first step is to write our hypotheses. And so we start with the null hypothesis, which is H subscript 0. And I can simply say that my sample mean is equal to the population mean. Or I might say that the population mean is equal to 75. This is a no difference hypothesis. It says that it's all equal, the same, there's going to be no difference. The alternative hypothesis is that my sample mean is not equal to the population mean, or it could be that the population mean is not equal to 75. So this is 2 ways of writing the same thing. Either one of them are just fine, but we do need to have a null hypothesis and an alternative hypothesis. This is the one I want to see as a researcher, but I have to set this up. This is the one that I'm actually going to test. Okay, let's try step 2. For step 2, we need to define our critical region, and we need some information to be able to do that. First of all, we need to know that we have an alpha of 0.05, that is our alpha, preset alpha level, and we have a two-tailed test. And in order to determine what are going to be those critical boundaries, what we need first is our degrees of freedom. So I have N equals 49 for how many people were in the sample. So N minus 1 is our degrees of freedom. So our degrees of freedom are 48. Now, if you take degrees of freedom of 48 and you look at your t-table for a two-tailed test at alpha 0.05, our critical boundaries are going to be plus or minus 2.02. So I've set my critical boundaries, and this is what my t-statistic needs to be more extreme than in order for us to find statistical significance. So let's figure out that t-statistic in step 3. Okay, for step 3, I've put down some important information we're going to need to make our calculations. First is the t formula, which just says it's the mean of our sample minus the population mean divided by the standard error of the mean. And in this case, the standard error of the mean is figured by taking the square root of variance divided by n. So have we been given the variance? No, we haven't been given the variance, but we have been given the standard deviation. And so the standard deviation, we can just convert it into variance by squaring it, basically. So 14 times 14 gives us 196. So our variance is 196. So if we have 196 divided by our N of 49, that gives us the square root of 4, if you do that division. So the square root of 4 is 2. So that means that our standard error is 2. So now we have everything we need to know to be able to figure out our t-statistic. So we plug in our mean of 69 minus the population mean of 75 divided by our standard error of the mean of 2. So 69 minus 75 is a negative 6. divided by 2. So our critical value, I've got to put this up a little bit, our t is equal to negative 3.00. And now we need to make a decision whether or not this is statistically significant.
Our last step is to make a decision. Are we going to reject the null hypothesis, or are we going to fail to reject the null hypothesis? Well, in this case, our observed t of negative 0.3 is more extreme than the preset alpha at negative 0.202. That was the t value that was associated with a preset alpha of a two-tailed test at 0.05. So our t-test shows that we're going to reject the null hypothesis. And we say that fatigue actually significantly impacted performance on an observational learning task. And so I want you to pay very close attention to the way that this is written at the top. We have t, that is our t value. We have 48, which indicates the degrees of freedom. And then we have equals and the actual t value that we found. But this next part is really, really important. The p-value that we found was less than 0.05, which meant that there was less than a 5% chance that we would find our t-value if the null hypothesis were true. In other words, our mean is so unusual that we're going to reject the null hypothesis. We're going to say, no, what's happening with our sample is very different than the normal population. Okay, let's go to the next video where we're going to try another one.